Okay, so now we're going to use the function from part A to figure out part C. How many hours will the number of bacteria double? So if I start with 8,000 bacteria, that was my P sub 0 amount. Double that is 16,000. So that means I want to figure out when, at what T, does this occur at? So in my original function, I'm going to pull it up a little bit so that you guys can see it. I had 8,000 e to the ln of 5/4 times t. I'm going to set that equal to 16,000 and solve for t. So 16,000 equals 8,000 e to the power of natural log of 5/4 times t. First thing I'm going to do is get that e term by itself. I'm going to divide both sides by 8,000. So I get 2 is equal to e to the natural log of 5/4 times t. So remember that little bit of work we did in part B where I kind of had to manipulate that exponent? I'm going to do that here too. I'm going to put the t in front of the natural log, and I'm going to use the exponent property to move that t into an exponent. So it becomes e to the power of natural log of 5/4 t. Now I'm going to use the same rule that I used in B, where if I take a base and a log, and the log is in the exponent, these guys cancel each other out. So I'm left with 2 is equal to 5/4 to the power of t. But I'm still left with the problem of t being in the exponent here. So what I want to do, sorry guys, is get that t out of the exponent. So I'm going to take the log of both sides, and this is a 2, that's 5/4. I'm not going to worry about trying to get the log and the base to cancel. I'm just going to take natural log of both sides because we're dealing with e, so taking the natural log of both sides is a good way to do it. So I get natural log of 2 is equal to natural log of 5/4 to the power of t. Now I'm going to use that property again where I take the t, move it from its exponent stop to the front, and I get natural log of 2 is equal to t times natural log of 5/4. To get t by itself, I'm going to divide everything by natural log of 5/4 so that those cancel out, and this is my final answer. T is equal to natural log of 2 divided by natural log of 5/4, which I know we can't use calculators in here, but if I say how many hours and I tell you the answer in natural logs, it's not really a way of knowing if my answer is legit or not. So use your calculator just to check. This comes out to about 3.106 hours, which if you figure after 2 hours, we got 12,000 bacteria.